put this now. Okay, so workshop 1, as you are seeing your PDF handout, the first task is to fill in the values of the variables as the Java statements execute. So let's say that you haven't gone through the lectures yet. So I just want to give you a brief explanation of what variable is. So here you are seeing that int voltage equals to 0. So voltage is the name of the variable and int is its type. So we have several types: int, double, float, character, etc., depending on what you want your variable to be. So now it says that fill in the values of the variables as the Java statements execute. So here we can see that we have 1, 2, 3, and 4 variables, which is voltage, which is named as voltage, power, current, and resistance, and all of them are initialized as 0. So when I say initialized at 0, that means we are assigning value 0 to that particular variables. As you can see, all of them are int, so the type of that variable is an integer, so you can only assign a whole number here, either positive or negative. You cannot assign decimal numbers because the type is integer. So of course, the answers to these ones here will be 0, 0, 0, 0, because we are just initializing them to 0. So our answer to voltage, power, current, and resistance will all be 0. Now, second here, task 2 is you are changing the value of current to 10 from 0. So next time when you are filling that, the value of current will be now 10 here. Next up is you are changing the value of resistance to 1, as you can see here. So in the next slide, let's say if you are changing the value of resistance to 1, then it will become 1 from 0. Next up is you are saying that resistance equals to resistance minus, resistance equals to resistance times 2. So your value of resistance is 1 and times 2 is going to give you 1 times 2, which is 2. So now the value of resistance will be 2. Again, your fifth task is voltage equals to current into resistance. So your current is 10 here and your resistance is 2. So your voltage will become 20. So here you can see that your voltage is 20. Next up is power equals to current times voltage. So power, which is initially 0, it is equals to current time voltage, which is 20 into 10, which will become 200. So now the value of power is 200. Again, we are changing power to something. So whatever is the output of your right hand side will be assigned to power. So that is your 7th task there. Now this one is interesting. So 8.1 is interesting, and I want to know what will be the answer for this one before I show you the answer. So it says that power equals to 1 by 2 times power. So
100.
May I please know in chat what will be the answer, or just unmute yourself and let me know?
100.
Okay, and why so?
Because we're dividing 200 by half, but divided by 0.5.
The actual power, the original value of power 200, we are dividing it by 1 by 2.
No, we are dividing it by 2. We are dividing it by 2. Yeah.
So you'll be surprised that answer is not going to be 100. Your answer is going to be 0. Okay. Why so? Because whenever you divide an int by an int, the answer is always an integer and not a double. So I know that 1 by 2 is 0.5, but as it's an int divided by an int and you are storing everything inside an integer, it will just take the first part, the 0, and not the decimal part. Okay, so if you see this one,
Okay, got it.
Yeah, so if you see this one here, right, you can see that the answer is still 0. The reason being, I'm explaining again, as we saw here, right,
So it is not float point, right? So it's not float point. Yeah.
No, because all these attributes were initialized as an integer, right? So whenever you divide an int by an integer, this was again discussed in lectures, but that's completely fine if you haven't got the time to go through it. So if this one is an integer and this one is an integer as well, so int by an int is always an integer. It doesn't even round it up, so it just truncates it. So let's say if your answer is 0.5, right? You might think that it might round it up, but no, it just truncates this part and it just gives you an integer as an answer. So the answer to 1 divided by 2 will be 0. And of course, whatever power is, it doesn't matter. 0 into anything will still give you 0. So that's how you're getting a 0 here. So this is very important concept, and that's why I'm repeating that you shouldn't forget an int divided by int is always an integer. Now, if this was the case, so let's say if I would have written like this, 1.0 divide by 2, then the answer would be 100, because then 1.0, if any one of the variable is double, then the result is double. So it will make this variable double as well. So here, if I'm writing 1.0, that means it's a double, and the result will be a double. So then in that case, it will be 0.5, and times power is 0. Times power, which is 200. So that will become 100 as an answer. So I hope that is clear, and that is the end of your first task. Now, just to explain you what I've said, and this is just the output of what we have done already. So I just put it in a program and then see the output. Yeah, so integer division, if a division involves two integers, the result will be an integer and the remainder will be discarded, not even rounded. I repeat again, just discarded. So 8 divided by 4 will be 2, of course, but 9 divided by 4 will be 2 point something, but still the answer is 2, because int divided by an int will always result an integer. Yeah, so I'm just looking at the chat at the same time as well so that I don't miss questions, okay? Yes, the answers will be, so I'll upload this particular PPT online. So there will be a link to this PPT, and once you click on that link, you will be redirected to exact same thing what you are seeing on the right-hand side. Okay, so a double division. So let's say if your division involves at least one double, as I said, the result will be double. So if you see here, you can see that 8 divided by 4.0. So 4.0 is a double. So that will result in 2.0, and 9.0 divided by 4. Again, one variable is double. So that will result in 2.25. So that will give you exact result with exact precision. Now, sometimes you need to convert a double to an int. So you need a conversion between a double and an integer. So that's what we called as a typecasting or typecast. You are explicitly converting it. So either if you know the value of the variable, then you can just say 4.0. But let's say if this was a variable, so let's say this was power instead of 2, then you can just typecast it by writing double in opening and closing round brackets, and that will convert that variable to double. If you want to convert this side particular variable to a double, then you do the same thing. So this is called typecasting. You are converting an integer to a double.
Can you explain the conversion again, please?
Sure. So see, if this was the case, it's pretty straightforward. You put 4.0 and it gets converted to double, right? I might give you just one more example here so that it's easier for you. So let's say I have a variable a, which is an integer, and then I have a variable b, which is an integer as well. But I want my answer to be a double, okay? So if you go int by an int, that will give you an integer. So answer won't be double. So I need to make either a double or b double. How I can do it is just write this double in front of them and it will become double. Make sense?
Yes, thank you.
No worries. Okay. So now again, it's your task to let me know the answers of these ones. What is the result of each of this statement? This one is an integer, this one is an integer, storing inside an integer as well. So the answer will be 5. I might give you some time to work this out, and if you can put your answers in chat, that will be good, and then I'm happy to discuss all the answers as well. Yes, so you need to put double in brackets. Otherwise, it will give you an error. And the important thing is Java is a case sensitive language, okay? So it needs to be if you're writing capital D instead of small d, that won't work. Yeah, so take some time and work out these answers, and then we'll discuss this.
Excuse me?
Yeah.
Like it is written double C, so we need to give the answer of C in doubles?
So you just need to give what will be the answer of C. So what will be the value of C? That's it. It doesn't matter what side this is. So what will happen is, yeah, I need to tell you this. So always the right hand side will get executed first, okay? So you just need to work out what will be the right hand side, and that will be your result. All right, I can see a few answers. So let's just discuss the answers. First one is pretty straightforward, right? So int divided by an int, and it will result an integer. So the answer is 5. Now, second one, so this precedence and association was discussed in lectures. Division and multiplication have higher precedence over addition and subtraction. So if you go from here, division has higher precedence. So 11 by 2 will give you something, but as it is an int by an int, right? So it will result an integer. So this side will be 5, and 5 times 4 is going to be 20. And again, it is stored inside an integer, so the answer will be 20. If any point in any of this example, if you don't understand, please feel free to ask. No question, as I mentioned, is silly question. So if you don't understand, it's very important for you to understand all these concepts, okay? And I don't mind running over time, and I'm happy to stay back and answer your questions. So yeah, so 11 divided by 2 will give you, again, it's int divided by an int, so it will give you an integer, and times 4 is 20, so the answer is 20 here. Now this one, again, this will be executed first, so int divided by an int is still an integer, and times 4 is going to be 20, but you are storing it inside a double, okay? So if you are printing C is a double, so it will go 20.0 here, just because C is a double. Now this side, this one is a double, so if just one, even if one argument is double, then it makes your whole equation as double. So 11 divided by 2 will give you exact precise answer, and times 4 will give you 22.0. Again, it's a double, so it will get printed as a 0.0.
Sorry, excuse me. Can I ask a question, please?
Yeah.
So in the lecture, you stated that the hierarchy for the operators, you mentioned that multiplication is higher than division, though.
Yeah. So that's, they both have higher precedence over addition and subtraction. So division and multiplication have higher precedence over the addition and subtraction, but it depends on which one appears first, okay? So there is no rule as in which one is higher than, whether division is higher than multiplication or multiplication is higher than division. But when multiplication and division, they both are together, then you need to apply the second rule, which was association. So then you need to go from here, and whichever appears first will be your first precedence.
Oh, okay. So the whole operation is read from right to left, but in terms of operators, it's left to right. Is that correct?
Yes. Yeah.
Okay. All right. Got it. Thank you.
So when we see this expression, we can just say that this part is getting executed first and then getting assigned to this one, okay? I think I might just clear, because other students might have this question as well. So if we just go to the lecture slide that was uploaded. Was that in lecture 1 or? I'm not sure. Did you see that in lecture 1 or lecture 2? Any idea?
It's in lecture 2.
Okay, yeah, precedence here. Yeah, so if you see this precedence from highest to lowest, right? So it multiplication and division has higher precedence over addition and subtraction, but the association is from left and right. So whenever there is an equation, you read it from left to right. Does that make sense? So that's the case here as well. So when you read it from left to right, you know that division appears first as compared to multiplication. So that is the second rule. When division and multiplication are together, then you need to check the rule of association, which says that it needs to be read from left to right. If that makes sense. All right, so back to what we had. Yeah, and just just more information. So brackets have more precedence over everything else. Okay, so as soon as you put some brackets in, it changes your whole equation. So let's just say that if I would have put a bracket here, 2 times 4, then this would have been executed first and then that. Okay, so next up is double 11 by 2. So you see how this 11 is casted to a double. So your 11 is a double now. So that will be 11.0 divided by 2 times 4. So again, it is getting stored inside the double. So the answer will be 22.0. Now this one, this side is an integer. Okay, so 11 divided by 2, it will give you an integer value and not double. And then it will be multiplied with a double value and stored inside a double value. So the answer will be 7.5. And for this one, again, this will be int divided by an int, which will give you an integer, and times 1.5 is going to give you a double, but you are storing it inside an integer. So whatever is after point, that will get truncated, right? And okay, so this one is error. Why? Because there is no way that you can convert and double to an integer. Okay, so whenever you try to convert a double to an integer, it will give you this error saying lossy conversion from double to int. But you can forcefully make this to be an integer by just casting this one to an integer. So let's say after all this, you have calculated your equation, you can just go and say int here and cast it to an integer. And then in that way, you will be able to make your program work. But if you just leave it like this side is double and this side is integer, that conversion will never be possible, and it will give you this error. Any question
Hello.
on? Yeah.
Can you explain double F, please?
This one? Yeah, sure.
Yeah.
Okay. So 11 divided by 2 will give you 5 point something, yes? Yeah, but that 5 point something won't be counted. So this is an integer, so it will be only 5. So 5 times 1.5 will give you 7.5, and again it's stored inside a double.
Right, thank you.
Okay, any question?
Sorry. Yeah, for the last one, if you were
Mm-hmm.
to force it and write an integer for the last equation, would it show up as a 5 or as a 7?
So
because as 1.5, would that be counted as an integer as well and be multiplied by 1?
So if let's say this one is same as the upper one, right? So the answer is 7.5. But if you are casting it to an integer, that means the precision will be lost and the answer will be 7.
Yeah, but it will still multiply with 1.5 then.
No, we are already multiplying it with 1.5, right?
Yeah, but that is a double.
No, what I mean is once you calculate this one, then you have then you convert it. Sorry, then you cast it to an integer.
Okay.
We can say it now if you want. So let's just say that so the equation is 11 divided by 2 and times 1.5, right? And we are trying to print that out. So in this case, if we just try and print it out, it will give you incompatible types, possible lossy conversion from double to an integer. So now let's say we are trying to, so let's first go to your question. So if we are making only this integer, this is already integer, right? So let's say we go and compile this one. It will still say that incompatible types because this is a double. So what we are doing with this is we are just making 11 as an integer, but that's again an integer. We don't need to do it. So what you can do is once this equation is calculated here, then you go and convert it to an integer. So then it will successfully compile, and if we run that one, then the answer will be 7. Okay, so that's how you explicitly convert your double to an integer by typecasting it, by forcing that typecast. Ready. So yeah, that's the answers. Answer for G is not there because it was an error. Now I just need to see the chat. Okay, I think no questions for me, so should be fine. Yeah, so type compatibility is in general, a variable of one type cannot store a value of another type. So as just how we've seen that double cannot be stored inside an integer. So in some cases, though, it's possible. So let's say that you have a variable named counter, which is of type integer, okay? So when you try to assign a value of 2.34, it will give you a compile time error, just the error that we saw before, possible lossy conversion, because you cannot store a decimal to an integer. But when you try to assign a character A, that will still work. So that won't give you a compile time error, but it will still work, but it's a poor style of coding, okay? So it's not incorrect, but it's a poor style of coding. Why this is allowed? Because character is stored in an int representation. So if you go to the lectures, you will know this. So character is of integer type. So that's why that's the reason that this is allowed. How it will be stored inside this int counter is the ASCII value of A, the Unicode number representation will be stored inside the variable counter. So here it's written that not incorrect, but poor style. So counter is assigned the Unicode number representation of A, which is 97. Now, mixing numeric types. So yes, Java does allow mixing of byte, short, int, long, float in any of the arithmetic expressions. So when we are talking about arithmetic expression, we are talking about addition, subtraction, multiplication, division, and modulo operator. So in that case, if your one argument of the operator is double, and the other argument will be converted to double and the result will be double. So let's say if you are saying 2.0 plus 1, it will convert the 1 into double and the result will be 3.0. Otherwise, if one argument is a float, the other will be converted into a float and the result will be float. If one is long, other will be converted into long and the result is long, and so on for int. The only different case is for short and byte, okay? So if a variable is of type short or if a variable is of type byte, the other one will be converted to short or byte depending on which one it is, but the result will always be an integer, okay? And the reason for that is for many languages, the least used type in arithmetic operators or in arithmetic expression is an integer, okay? Let me give you a simple example. So let's say you have declared 2 bytes, okay? So byte is a data type. So you go and say, this one, maybe I'll just go and write it here. Yeah, so let's say you are declaring a byte named A and the value to that is minus 128. And then you are declaring a byte B, the value to that is minus 1, okay? Now we are performing A divide by B. You know that they both are byte, okay? So you can assume that the result will be stored in byte, but that's not correct. So minus 128 divided by minus 1, minus cancelled, and the answer will be 128. Now there is no way that 128 can be stored inside byte because the range of byte is from minus 128 to 127. So 128 needs to be stored inside an integer. So that's one of the reasons when you have 2 shorts or 2 bytes, the result will be still an integer. Okay. So just thinking, there is this simple rule that the result is always going to be wider type of the type that you have chosen. So if this is a short and this is a short, the wider type to short will be integer. If if there are 2 bytes, the wider type to the 2 bytes will be an integer. So that's the reason that result is going to be stored inside an integer, just to avoid surprises. That's the case only in these 2 cases, because bytes and shorts store very less possible combinations. So 1 byte can only store 8 bits and short is just 2 bytes, so 16 bits. Okay, so again, this is an exercise. So given that these are the values, do the following compile? If so, what is the type of the result of the following? So I'll just show you one. So double D is a double, F is a float, B is a byte, and I is an integer. So D plus F, based on the rules that we have discussed here, D plus F is a double plus float. So double is higher than float, wider than float. So the answer will be double. So if you see, answer is double. Okay. I'm going to give you 1 minute to just work these 3 out, and then we'll discuss the answers. Alrighty, so I've got few answers in here. So a double plus float, wider is double, so the result will be stored inside double. A float plus byte, wider is float, so the result will be stored inside float. Byte plus byte, it was just discussed in the previous slide that if you have 2 bytes or if you have 2 shorts, the result will always be an integer. Reason being, I have explained it. So for this one, the result will be integer, and of course an int times an integer, the result will be integer as well. So these are your answers. Let me know if you have any questions with this. Just to explain you slightly more, so you might have noticed that while declaring a float f, we have written 1.2 and then f here. This f can be capital F or small f, it's fine. But why we are writing that f in declaration? That's because if we don't write it, by default 1.2 is a double literal, okay? So it will be considered as a double. So during compilation, all the floating points will be considered as double if you don't force it to be a float. So just in case, if you want to be a precise and if you want to say the compiler that 1.2 is going to be a float and not double, then you need to put a F after that in declaration. Excuse me. So now mixing with character. So let's say you have one type as a character. So Java allows the mixing of character with numeric data types. As I mentioned earlier in lectures and in workshop as well, a character argument of a binary operator is always treated as an integer. Okay, so you might write it inside a single quotes as an A, but the binary representation of that character will be treated as an integer. And that's why the result is an integer. So if there is one character type in your equation, the result is going to be an integer. So let's say, do the following compile. If so, what will be the output? Double D byte P character CH, double and a character. Again, you know that double is the highest, so the result will be double. And I'll ask you to work this two out. Yep, so I've got a couple of answers. So first one is double and character. Double stores 8 bytes, character stores 2. So answer is double. Next up is byte plus character. Again, character is 2 bytes, byte is 1 byte. So it will take the bigger one. And as we mentioned in the previous slide, the representation will be an integer. So the answer is integer. Character plus character, answer is an integer. Now mixed types in assignment. So as a special case, we can assign an integer value to a double variable, but not vice versa, as we have seen. So you can still say double C equals to 2. Okay, so you are assigning an integer value to a double variable. But if you try to assign a double value to an integer variable, as we show, it will give you an error saying incompatible types, lossy conversion, and you need to force it. So in general, Java performs the following implicit type conversions for assigning a value to a variable of different type. So byte can be assigned to short, short can be assigned to integer, integer can be assigned to long, long can be assigned to float, and float can be assigned to double. Byte is of size 1 byte, 2 bytes, 4 bytes, and so on. Now, these are all considered widening conversions because we are going from a narrow type to a wider type. So that will work perfectly fine, and it's an implicit conversion. Okay. However, in some of the cases, your precision can be lost. So let's say if you are trying to convert an integer type to a floating type, then some precision can be lost. Now, this is again the implicit conversion. So are the following statements allowed? And if so, what is the value assigned to the left-hand side variable? So what will be the value that will be assigned to the left-hand side of the variable? Given that D is a double, I is an integer, B is a byte, and character is a CH. So if you are trying to assign an integer to a double, so this will be a double. I'll give you some time to work this out and then we'll discuss the answers. All right, so we might just discuss the answers as we are running out of time. So first one, you are assigning an integer to a double. So the left-hand side will be a double. Second one is you are assigning a double to an integer. So the output will be an error, as mentioned before, that you cannot store a double inside an integer. Next up is you are assigning a character to a double. Again, this will be treated as integer. So yes, possible, and the answer will be double. Why 65? Because character A's ASCII representation is 65. Now CH to B, which is again character A to byte B. So answer will be an error. Again, as I mentioned, because byte is of 1 byte and character holds 2 bytes. So again, you are trying to assign something wider to a narrow side. And next up is CH equals to B. So B is a byte and CH is a character. Of course, it will be accepted, and the answer. Oh, okay, yeah, that's error because whenever we talk about characters, it's an unsigned, whereas byte is signed. So with a byte, you can assign both positive and negative values, but character is unsigned, and you can see that in the table that is given here. So if you see this table, ASCII table, you'll be able to see that it starts from 0 and it ends at 126. So more on ASCII table is given to you in lectures. And why just 126 and not till 256? Because the range of character is from 0 to 256. So all these things are explained in the lectures. Yep, so as character can only store positive or signed value, unsigned values. That's the reason it's giving you an error there. Yeah, because character is unsigned and bytes is signed. So just in this case, it was okay because the number is positive, but just imagine that the number is negative and then you're trying to assign it to a character. It won't work. Now, those were just going from a narrow type to a wider type. So those were implicit type conversion, but explicit type casting or explicit type conversion is something where you are forcing it to convert from one data type to another data type. And so let's say if you are trying to convert a double to a float, or you are trying to convert an integer to a short, and so on. So to make a narrowing conversion, we have to explicitly tell the compiler that you need to do a typecasting, okay? And we do it using this format, right? So let's say you have a variable named x and the value of x is 12.32, but now you want to store that x inside an integer, okay? If you don't typecast it like this, then it is going to give you an error. So this is what you are doing, an explicit typecast. So you are making your x, which is of type double, to int and then storing it inside an int. So this will work. Now, what's the value of the b? So we'll just see the value of this one. So it's 12 because it got converted to an integer. Now, what's the value in b? So int of I is equals to 256. So the value of I is 256, but now you're trying to convert it to a byte. The answer will be 0. Why? Because when you will convert this 256 into binary, it will look something like this. So let's say when you convert 256 into binary, the value is this, okay? And and then when you try to store it inside a double or an integer is 4 bytes. So then representation will be like this. And you can see that the 1 byte that is used is all zeros. And if you see the representation of byte, a byte can only hold 8 bits. So these 8 bits are all 0. That's the reason the result will be 0. So you are converting this 256 into byte, and byte can only hold 8 bits. So it's holding least significant 8 bits, which are these ones. And all this, if you convert these ones to a decimal as well, the answer will be 0. So that's the reason that the answer in previous example is 0. Excuse me. Yep, so this is again mentioned in lectures, the range of all the data types, but just have a quick look. So type byte, the memory used is 1 byte, and 1 byte is 8 bits. So the possible values can be 2 raised to 8, and the size range is from this to this. Short holds 2 bytes, and again, as I said, 1 byte is 8 bits, so 2 bytes will be 16, so possible combinations will be 2 raised to 16. Int holds 4 bytes, so memory used is 4 bytes. 1 byte is 8 bits, so 4 bytes will be 32 bits, and 2 raised to 32, and so on. So these are all the size and possible ranges and possible values and memory used by each of the data types. Right, so next up in your handout is to consider the following programs and to see whether they'll work or not. A character is again, a character will hold 2 bytes because that's in Unicode representation. So a character will hold 2 bytes in Java. Now consider the following programs. Will they work? If they will not work, what can be done to allow the programs to work? And if they will work, what will be the output of this program? So go through this program and see whether that's going to work or that's going to give you an error. So just let me know this first program, is it going to work or will it give me an error? Yep, so most of you are saying error. That's correct answer. Why so? Because you are trying to assign a double to an integer. Okay, so you have defined int number as an integer. You have defined double number as a double, but then you are trying to assign a double to an integer without explicitly typecasting it. So the answer is going to be sorry, it won't compile. So the answer is error for this question. So next program is this one, changing character program. So just have a look and let me know what will be the output. And just to mention that the value in ASCII is L for number 76. And you can always refer to the ASCII table and see. It's also in your handout here, the ASCII table. Yeah, it will definitely work. Yeah, so that's correct answer. I'm just looking forward to answer what it will output. Yeah, cool. So I've got one answer. So what's happening here is you have a variable called number of type integer and the value to that is 76. And you have a character variable of type character and which is assigned a character E. Now you are trying to print that character. So character before assignment, and it will be straight away printed this one, right? Because that's what holds inside the character. So answer to this will be E. Now what you are doing is you are assigning this number, which was 76, to character, but by typecasting it to character. Okay, so this 76 will be typecasted to character and L will be stored inside this character. So when you print it out after assigning, the answer will be L. So before assignment it's E, after assignment it's L. Yeah, I think this one is the last. Yeah, this one is the last program for you to work it out. Okay, so just to so you don't waste time. So this will work, of course. I'm just looking for the 3 print statements, what it will print.
I have a question.
Yeah.
In the system out println, do you have to have the quotation marks after every like plus thing, or can you just do number 1 plus? Okay, cool.
No, that's just for a space to get print in. So if you want a space to print in, yes, you do need to.
Yeah.
But if you don't want a space to print in, then it's fine. And plus is for concatenation here, not for adding at the moment, because it's getting concatenated. So what will happen if you don't put a space in here is it will add those 3 numbers. So it will go number 1 plus number 2 plus number 3. So it will give you sum. But if you want to print out number 1, number 2, and number 3 individually, then you need to concatenate it with a string. So that's how it's a string. Otherwise, it will be just a number. I might just show you. I'm changing this division class name to hex because in Java, your file name and your class name needs to be same. Otherwise, it won't compile. Yeah. So you see how it's getting printed as different numbers. So here we were trying to print out number 1, number 2, and number 3. So number 1 was yeah, the output of this one was 2. So number 1 was 2, and 1 was number 2 was 1, and number 3 was 3. So let's say just in case if we don't concatenate it with a string, so that won't be a string anymore, and we decide just to leave it like number 1 plus number 2 plus number 3 without a concatenation to a string. So now it's not a string anymore, and then we just change it, compile it again, and run it. And you'll see that it has become 6 now, because then it will just consider the addition of those 3 numbers. All right, so the output of this will be 213 and 9, 4.54 and 4.5. So for those who are saying error, let me just explain. So all these ones, number 1, number 2, 3, 4 are integers, and number 5, 6, and 7 are double. So number 1 is an int divided by an int. So this will work, and it will give you an answer as an int. Percentage is a modulo operator. The output of modulo operator is a reminder, okay? So when you do 5 modulo 4, the answer to this will be 1. So please make sure that this percentage is a modulo operator, and it gives you the reminder of the 2 numbers. Now, this one is 2 and this one is 1. So you are adding number 1 plus number 2. So the output of number 3 will be 3. And the number 4 is again an integer. So you are going number 3 plus times number 3. So 3 times 3, which is 9. So of course, when you are going to print number 4, it's going to print 9. Number 5 is number 4 divided by 2.0. Doesn't matter if this is an integer, but you are making this one as double. That means you are making both the number as double, okay? So number 4 was 9 divided by 2.0. So it will give you 4.5. And again, number 5 is double. So it will get stored inside the double. So here 4.5 is the answer. Number 6 is number 4 is an integer, divided by 2 as an integer as well. So answer will be in the form of integer, but you are storing it inside a double because number 6 is double, if you can see here. So then it will become 4.0. Number 7, 4 is an integer, divided by 2 is an integer, but now you have decided to make an explicit typecast and you are casting this number 4 to double. So now number 4 is double. Double divided by an integer will give you a double as an answer. So number 7 is 4.5. Any questions?
Yeah. Sir, I thought you mentioned earlier that declaring the variable of a double has to be in a double format as well. So I thought double, for example, double number 5, shouldn't it be 0.0 instead of 0?
It does it implicitly. So even if you go just 0, number 5, so right after this, if you just go and print system.out.println number 5, it will still be 0.0.
Oh, so there isn't any error even if you put in the wrong format?
No, that's not a wrong format. So we have always said that integer to double assignment is completely fine because integer is narrower part as compared to double. So that's completely fine. It will implicitly convert it to double. So you know this one is double and this one is integer. So when it is getting assigned to number 5, it will be 0.0.
Oh, okay. Thank you.
And yeah, and that was the case with all the previous things as well. You can always assign an integer to a double, and that's what we said when we said implicit conversion. So this slide here, that you can always store an integer inside a double. See how this was an integer I, and then you were storing it inside a double, and the output was a double. So that's the reason it won't be, this program will compile and it won't give you any error here. So that slash is for division. So when you divide, then you are expected to get answer either in a whole number or in point form. So when you say 5 divided by 2, you'll get 2.5 or something. But when you say modulo operator, percentage operator, that means you are just taking the remainder. Okay, yeah, so that was the last exercise for you, but you still need to do this at home because that's what it says in your handout here. So steps in programming development, background reading to be completed by you. So this is just an explanation of how you can understand the problem and design a solution from that problem. And it's very important that you go through this before your lab, because in the lab you will be given a program description and then you need to start coding based on that problem. So this is an exercise that you need to complete it by before your lab. And if you have any questions, again, you can ask me anytime. So I will be available for lecturers consultation. I think I'm gonna put it on Wednesday or Thursday. So I will upload the details on LMS today, and links to the labs will be uploaded again on LMS. So please make sure that you check your LMS. So now in your labs, there will be tutors assisting you. There are 4 tutors. So in lab, there will be 2 tutors. For Bandura instance, we have labs on Wednesday and Thursday. And for Bendigo instance, we have a lab on Friday. I am handling Bendigo instance. So I will see you on Friday from, I think it's 1 to 3. But for Bandura instances, there will be 2 tutors in the lab, and they all are experienced, so you can ask as many questions you want. Now, yes, so they will expect you to download PuTTY, and I'm just putting it in chat. So the software that you need to download is Putty. And the editor that we are going to use throughout the semester is VI editor, also known as VI modified editor. Once you download Putty, you can open VI editor inside itself. For those who have programming knowledge and for those who want to use IDE, so any integrated development environment like Eclipse or anything, that's completely up to you. But when you submit your assignment and any of the tasks that we have asked you, please make sure that it should work in VI editor. That's our concern. So it should compile and run in Putty. For Mac users, you do not need to download Putty. Okay, so by default for Mac users, there is terminal. So all you need to do is just download a VPN, connect it to the VPN, and then open the terminal and start coding. Okay, so for Mac users, I repeat, you do not need to download Putty. Putty needs to be downloaded for Windows users. And all the instructions, I might just show you when I'm here. So if you go to your LMS here, excuse me. Oh, that's absolutely fine. I think if there is a group already created in Discord, then I might join that only. We don't need to do maybe Teams then. Yeah, that's completely fine. Just post an announcement in Q&A forum, and I might add to that as well. So no, there is no preference from my side. Anything is fine. It's just for sometimes students need a quick chat, and if they are finding problems with anything, connections and stuff, then it's difficult for them to write an email. So that's my only concern. If that allows you to have a quick communication, Discord is completely fine. And thank you so much, guys, for attending this session. It was really good, and we had a good interaction. I was expecting that no one will have anything in chat or no one will unmute themselves and ask, but I really like this type of sessions where you ask questions and I even learn new things as well. So thank you so much for turning up. Please make sure that you go through the recordings of lecture. And if you have any questions, you can come to my consultation. There are a few more things that I need to let you know, but maybe I'll just write an email so that you are on track and you can read that email. I just want to assure you that any help you need, I'm always there. So no matter if it's related to lectures, workshops, or assignments, or if you just want to talk, it's completely fine. You can email me anytime. So we are here to help. And yeah, thank you. And all the information that you need on how to log in to Let's CS from home is here. So you might need to download a VPN, and you can download Putty from here. So all the information is in here. For Mac users, you can just connect it using terminal. Then the information is here. Anyone who is using Ubuntu, you can use Putty. Sorry, you can follow these steps. Yeah, and if you have any problems downloading and installing Putty or any connect, so VPN, please let me know. So when you try to log into your Putty, please make sure that you just put in your student ID and not @students or anything. So it should be just your student ID and your password. Whoever is finding problems with Putty and wants to know can stay back, and I'm happy to assist them. No, so everything is from home. All the labs will be online, so you are not going to campus. Okay, that's it then. Thank you so much for turning up, and I will upload next week's lecture on Monday or Tuesday morning, and we'll have lecture workshop again live next week. And all the best for your labs. Please, please, please do turn up to your labs. That's very important.